Hello everyone and welcome to the MathDBase.com Anacast series. I'm your host, John Kisiedu. In this installment in the Development of Mathematics series, I will discuss ratios, proportions, rates and variations, Part 5, Variations. Variations are used to express the relationship between two or more variable or changeable quantities. This symbol is used to represent variation and is read varies as, or is proportional to. We learn in geometry that the ratio of the circumference of any circle, which is the length of its boundary, to its diameter, which is the distance from one side of the boundary to another, passing through the center, is the constant or fixed number pi, a Greek letter, which is approximately equal to 3.14 with a fraction 22 over 7. In symbols, we write c over d equals pi. We can rearrange the circumference-diameter ratio equation to become circumference equals pi times the diameter. If the diameter is tripled from 1 unit to 3 units, the circumference is tripled from 3.14 units to 9.42 units. And if the diameter is halved from 2 units to 1 unit, the circumference is halved from 6.28 units to 3.14 units. The circumference varies or changes as the diameter varies, and we write c varies as d, or c is proportional to d. The perimeter of a square is the sum of the length of its sides. If the perimeter is represented by p and the length of each side by s, then p is equal to s plus s plus s plus s. But since each of the sides has the same length, s, p is equal to 4 times s, or 4s. If a square has a side of length 2 units, then its perimeter will be 4 times 2, or 8 units. If the square has a side of length 5 units, then its perimeter will be 4 times 5, or 20 units. The perimeter varies as the length of a side varies, and we write p varies as s, or p is proportional to s. These variation expressions are also called proportions, since ratios of circumference to diameter and perimeter to side can be expressed as proportions. The ratio of circumferences, 3.14 to 9.42, is equal to the ratio of diameters, 1 to 3. And the ratio of perimeters, 8 to 20, is equal to the ratio of the lengths of sides, 2 to 5. The circumference-diameter relationship of a circle and the perimeter-side relationship in squares are examples of direct variations. As one quantity increases, the other increases. In a direct variation, the ratio of quantities is always a constant, a fixed number. In circles, we have the ratio circumference over diameter, or c over d, and the constant is pi. In squares, we have the ratio perimeter over side, or p over s, and the constant is 4. More generally, every direct variation statement, c varies as d, p varies as s, or x varies as y, has an associated equation. c equals pi times d, p equals 4 times s, and x equals k times y, where k represents a constant, to be determined based on the specifics of the problem. The area A of a circle varies directly as the square of the length of the radius, r, which is the distance from the center to the edge. The associated equation is area equals pi times the radius squared, or in symbols, a equals pi r squared. When the radius is equal to 1 unit, the area of a circle is equal to pi times 1 squared unit, or pi square units. When the radius is equal to 3 units, the area is equal to pi times 3 units squared, or pi times 9 square units, which is approximately equal to 3.14 times 9 square units, or about 28.26 square units. Hooke's law in physics, also known as the spring equation, states that the force F exerted by a spring on an object hung from it is directly proportional to the extension of the spring, x, that is, how much it is stretched, and can be written as F varies as x. Its corresponding equation is F equals negative kx, where the constant of variation k is called the spring constant. The negative sign is there because the force wants to restore the spring to its unstretched or uncompressed position. In an inverse variation, one quantity varies as the reciprocal of the other. In symbols, x varies as 1 over y. The associated equation is x equals k over y, where k is the constant of proportionality. In inverse variation relationships, as one quantity increases, the other decreases, and vice versa, and the product of the quantities is always a constant. In the study of sound in physics, Acoustic pressure is the difference between the normal air pressure at a particular spot in a room and the pressure felt at that spot when a sound is made. The acoustic pressure P of a sound emanating from a source, such as a radio or an MP3 player, is inversely proportional to the distance r that the sound travels. And we say that P varies inversely as r, or P varies as 1 over r, or P is inversely proportional to r. In chemistry, Boyle's law states that the pressure P that a gas exerts in a closed container varies inversely as the volume V if the temperature remains constant. In symbols, we can write P is proportional to 1 over V. The associated equation is P equals K over V, and solving for the constant K gives K equals P times V. If a gas exerts a pressure of 55 pounds per square inch, or 55 psi, in a container with a volume of 100 cubic inches, how much pressure would that gas exert in a 75 cubic inch container? Substituting in the numbers to solve for the constant, K is equal to 55 pounds per square inch times 100 cubic inches. The square inches unit cancels, leaving inches in the numerator, and K is equal to 5,500 pound inches. Now solving for the value of the pressure in the smaller container, P is equal to 5,500 pound inches over 75 cubic inches. The inches unit cancels with 1 in the denominator, and we have an increased pressure of approximately 73.3 pounds per square inch. A number of laws of physics are called inverse square laws because one quantity varies inversely as the square of another. The gravitational attraction of two planetary bodies relative to the distance between them, the force of attraction or repulsion of two electrically charged particles relative to the distance between them, and the intensity of light observed from a point source relative to the distance from that source are all described by inverse square relationships. The weight W of an object above the surface of the Earth varies inversely as the square of the distance d from the center of the Earth. If a woman weighs 115 pounds at sea level, and the radius of the Earth is about 4,000 miles, how much will she weigh at the top of Mount Everest, which is 29,000 feet, or about 5.5 miles above sea level? The variation equation is W equals K over d squared. Let's substitute the relevant numbers that we have to first calculate the value of the constant of proportionality. At sea level, we have 115 pounds is equal to K over 4,000 miles squared, which simplifies to K over 16 times 10 to the 6th square miles in scientific notation. Solving for K, we have K equals 115 pounds times 16 times 10 to the 6th square miles, or K equals 1.84 times 10 to the 9th pounds square miles. We now have the value of the constant of proportionality K, so on top of Mount Everest, the distance from the center of the Earth is 4,000 miles plus 5.5 miles, or 4,005.5 miles, and she weighs 1.84 times 10 to the 9th pounds square miles over 4,005.5 miles squared. The square miles units cancel, which simplifies to about 114.7 pounds. For a review of scientific notation, have a look at the decimal system series. In a joint variation, direct and inverse variations are combined in one expression, and one quantity varies directly as a second quantity and varies inversely as a third. In symbols, z is proportional to x and inversely proportional to y. The associated equation is z equals a constant k times x over y. We can solve for the constant of proportionality by writing k equals y times z over x. Z is directly proportional to x and inversely proportional to y. If z equals 8 when x equals 4 and y equals 5, then 8 equals k times 4 over 5. Solving for k equals 5 times 8 over 4, which simplifies to 10. When x equals 0.5 and y equals 2, z equals 10 times 0.5 over 2, or 2.5. Boyle's law, which only considers changes in the pressure and volume in an idealized gas, is contained in the ideal gas equation, or ideal gas law, which also considers the amount of gas and temperature changes. It states that the pressure P exerted by an ideal gas on its container can be represented by a joint variation. P is proportional to N times T and inversely proportional to V, where N represents the number of molecules of gas, T represents the temperature in the container, and V represents the volume of its container. The associated equation is P equals N times R times T over V, where the constant of proportionality R is called a gas constant. This equation shows that the pressure exerted by a gas increases as the temperature increases, and that the pressure decreases as the volume increases.